So we talked about how to write an equation from a table in another video, but what we're going to do now is look at how to write an equation from a verbal statement. So our learning objective continued is that we're going to be able to write the equation of a linear function in slope-intercept form from a table and from a verbal description. So remember what slope-intercept form is. It's y equals mx plus b, where m is our slope and b is the intercept, which is why it's been given the name slope-intercept form. Remember, that is available on your formula chart. It is not something you have to remember. All right, so let's take a look at this example. A balloon is released from the top of a 75-foot building. The balloon rises at a rate of 2 feet per second. Which equation describes the height of the balloon h after s seconds? Okay, so now after you've kind of read it, now you go through and actually look for your identifying words. So a balloon is released from the top of a 75-foot building, and the balloon rises at a rate of 2 feet per second. So we want to find which equation describes the height after s seconds. So now there's a couple of key words in here. We have this word rate, which probably more often than not is going to be our m. And then we know that we're trying to write an equation y equals mx plus b, only this time they're saying it's going to be h equals ms plus b, because h is the height and s is the time in seconds. So we're still looking for the m and we're still looking for the b. So the m, they gave us a clue word of rate of 2 feet per second, so our m is going to be 2. Now remember, b is the y-intercept, which is where an equation starts. So if we think about this balloon started on the top of a 75-foot building, and then from there it's going up. So it actually started at 75 feet. So our b value would be 75. So we're looking for an equation that looks like h equals 2s plus 75, which looks like it would be C. Okay, we're going to do one more example. So here we have an hourglass that's turned over with the top part filled with sand. So we have an hourglass. That's one of those glasses that has like the sand in it, and then you turn it over and it drains. What we know is that after 3 minutes, there are 855 millimeters of sand. After 10 minutes, there are 750 millimeters of sand in the top half. So we can see that as time increases, the amount of sand in the top decreases because more sand is going to the bottom. So we need to find an equation that represents this situation. So let's take a look at our answer choices just to see what kind of equation we're going to be looking for. All of our answer choices have a y and an x, and they're in that slope-intercept form order. So we're going to be looking for an equation that looks like y equals mx plus b. And remember that m is our slope or our rate, and b is our y-intercept. So if we remember from a word problem, our m, our slope, is our rate. They didn't really give us a rate in this problem, nor do we know how many millimeters of sand they started with. We only know the amount of sand left after 3 minutes and after 10 minutes. So we're going to have to do a little bit of extra work here, which means we're going to need to make a table so we can visualize more what we're going to be doing. So I'm going to make a table here. And I know that my minutes are going to go here, which would be our x values. And the amount of sand is going to go over here, which would be our y values. So I know that after 3 minutes, there were 855 millimeters of sand. And after 10 minutes, there were only 750 millimeters of sand. So that's really all the information we have. And what we have to have in order to write the equation is m, which if you recall is the change in y divided by the change in x. And then we need to find the y-intercept, which is basically how much sand we started with. So let's start with our slope, our change in y over our change in x. So our change in y, we want to see what is the difference here between 855 and 750. We can see we're going down, so it's going to be a negative number. And then 855 minus 750 is 105. So we know our change in y is negative 105. And now we need to find our change in x. So if we start at 3 and we go to 10, that's going up by 7. So our change in y is negative 105. Our change in x is positive 7. When you put that into your calculator to reduce that fraction, we're going to find that our m is negative 15. So I know you may be tempted to say, oh, well, there's only one answer choice that has negative 15 as a slope. However, I want to make sure we understand what that means. So what that means is that my change is negative 15, really over 1. So negative 15 is the amount of sand that releases for every minute. So that's why after 3 minutes, there were only 855 millimeters of sand. So if we want to figure out how much sand we started with, again, we're going to have to kind of work backwards. So we're starting with 3 minutes. So after 2 minutes, there would be 15 millimeters more of sand. So 855 plus 15 would get us 870. 1 minute would mean it has back another 15 millimeters of sand. So that's going to be 885. And then if we want to find what it started with, we've got to go to 0. So we add another 15, and that's going to be 900. So our y-intercept is going to be 900, which now we know, okay, C is the correct answer.